Welcome back, everyone. This is Professor Harry. In this video, we're going to go through some extra practice problems dealing with concentration calculations, dilution, and transfer. So let's begin. All right, try this problem on your own first, and then come back to the video and see how you did. Welcome back. So we want to know how many grams of sodium chloride are needed to make a 500 milliliter solution of 5 molar sodium chloride. My recommendation is to start by writing out the definition of the concentration units we want, which is molarity. And so that's going to be the moles of solute, which in this case is sodium chloride, over the volume of the solution in liters. We know that the volume of the solution is given in the problem, but we need to find the moles. The moles are calculated by taking the molarity times the volume. So we have 500 milliliters and convert that to liters. We can then plug in our molarity times the volume to get 2.5 moles of sodium chloride. We can then use that and multiply by the molar mass of sodium chloride to find out how many grams of sodium chloride we need. And that's going to be approximately 150 when taking into account significant figures. Let's try the next one. We already saw this one in the previous video, so we're going to skip it. All right. What's the molarity of acetic acid and vinegar, which is 5% acetic acid by mass? The density of vinegar is 1.01 grams per milliliter. Try this on your own, pause the video, and come back when you're done. Welcome back. So again, let's start by defining some of our key relationships. We need to solve for molarity, so we need the moles of the solute and the volume of the solution in liters. We're given the density, which is mass per volume of solution. We're also given the mass fraction, which is mass of solute per total mass of solution. So what you want to do is recognize which of this information you already have in order to combine it together to get the information we want. So let's just assume that we've got a 100-gram sample. And why do we do this? Well, it makes it easy because we know we have 5% acetic acid by mass, which means then our mass of acetic acid is going to be 5 grams. Then when we take the 5 grams, and if we divide by the molar mass of acetic acid, we can get the number of moles of acetic acid. We're going to then be able to use that here to solve for molarity. All we need to know now is the volume of the solution in liters. Well, again, we've assumed a total mass of 100 grams. So by using the density, and that's defined as 1.01 gram per milliliter, we know that if we assume we have 100 grams, we can find the volume in milliliters of the solution, and that's going to be 99.01 milliliters. If we convert that from milliliters to liters, we get the volume there, and then we can combine that with our moles of acetic acid to get the molarity. All right, in this problem, we have 3 solutions that are being mixed together. We want to know what's the final concentration of hydroxide ions, assuming that all of the volumes are additive. Well, again, let's draw some pictures here. We've got beaker 1, beaker 2, beaker 3, and we're combining them all together. So our total volume is going to be the sum. That means our total volume is going to be 62 plus 3, that's 65 plus 10, that's 75 milliliters. Okay? This is going to dissociate into sodium ions plus hydroxide ions. strontium hydroxide dissociates into the strontium ions and 2 hydroxide ions each. And then this is a non-electrolyte. It's an alcohol, which means that it's not going to matter. So we can organize that information in a table format here. Again, this is 0 concentration of hydroxide because it's a non-electrolyte. Our final volume is going to be the 75 milliliters, and we're asked to find the final concentration. So we're going to solve for each one individually and then combine them together. We can rearrange this equation, the dilution equation, and plug in our values for each set. And this was for our sodium hydroxide. And for our strontium hydroxide, we have to make sure we are accounting for the 2-to-1 ratio of strontium hydroxide to hydroxide to get us 90 millimolar. And we can then add those 2 molarities together to get the final concentration of the hydroxide ions in our beaker. Okay, let's try the next one. This is asking us to calculate the molarity given a 38.5% by mass hydrochloric acid solution and a density provided. Pause the video and try this on your own. Welcome back. So again, let's start by defining the information we know. We know that mass fraction is the mass of one substance over the total solution's mass, and molarity is the moles of the solute per volume of the solution in liters. We can find the mass of hydrochloric acid by multiplying the mass fraction times the mass solution. And the reason why we'd want to do that is because in the end, we need to know the molarity of HCl. And by using the molar mass, we can take the mass of HCl and calculate that. So that's going to be 0.38 from the 38% times, let's just assume that we have 100 grams of that sample. You could assume you've got 1,000 or 1,000,000 or 1. It doesn't matter. That would get us then 38 grams for 100 grams of solution. The moles can be found by taking the mass and dividing by the molar mass of hydrochloric acid. And the volume will be found by taking and using the density. Now here we assumed we had 100 grams. If we had assumed we had any other number of grams, let's say 1,000, then we would use 1,000 here. If we had assumed we had 1 gram, we would use 1 gram. If it told you you had 72 grams, then you would use 72 grams. We can then find the volume, convert to liters, and then plug that into our definition of molarity with the moles to find the molarity of our hydrochloric acid. All right, one more question. Pause the video and try this on your own. So we want to know how many milliliters of 0.6 molar strontium hydroxide would be need to be added to 1.4 liters of water if we want to create a hydroxide concentration of 0.3 molar. So this one's a little bit trickier because we're asked to find what's an initial amount based on a final amount. But again, if we write out our balanced chemical equation and draw some pictures, then that will greatly help to simplify the process. So we want to know the initial volume. We know that we've got 0.6 molar strontium think I'm going to run out of room here. Let's make these beakers a little bit smaller. 0.6 molar strontium hydroxide. Our final volume is going to be 1.4 liters plus volume 1, and this is 0.3 molar hydroxide. Okay, so we know that we started out with 0.6 molar strontium hydroxide, and that it's a 2-to-1 ratio of hydroxide to strontium hydroxide. That would mean that we would start with 1.2 molars of strontium hydroxide. By using the dilution equation, we can set the initial concentration with the unknown volume equal to the final concentration and the final volume. Now again, we have to add those two together because it's unknown. We don't actually know what the final volume is. We're adding 1.4 liters to it. So if you take and distribute out, we're going to get that that's equal to 0.3 molar times the volume plus 0.42 moles. Now, remember, when we're taking molarity times the volume in liters, that's equal to moles. And that's what that turned into there. So we've got 0.9 molar times the volume equals 0.42 moles. Rearranging to solve for the volume gets 0.467 liters. Since we're looking for it in milliliters, we calculate that out and get that equal to 467 milliliters. That's it for this video. Thanks for watching. If you have questions, ask on Piazza, in office hours, or recitation. Have a good day.